Welcome back, everyone. This is Mr. Longo here, and we're going to talk about solving radical equations. So the first thing we need to talk about is inverse operations. So this is something we've already talked about before. When we are solving for x, and you need to square root both sides to get rid of an x squared, we have x is equal to plus or minus 2. But when you need to get rid of an x cubed, you have to cube root both sides. And that's going to leave you with x is equal to 2. There's no plus or minus on odd roots, only when you have even roots. So keep that in mind, because remember, 2 times 2 times 2 would give you an 8. If this was a negative 2 times a negative 2 times a negative 2, that would give you a negative 8. So plus or minus only goes with even roots. To get rid of a square root of x, you just have to square both sides. So that's going to leave you with x is equal to 9. Same thing with cube roots. You just have to cube both sides. And that would give you x is equal to 27. And the last one is when you have a rational exponent. And it's pretty much the same thing. This is x squared, and it's cube rooting it. So to undo a cube root, you'd cube it, and undo a squared, you'd square root it, which basically means all you have to do is raise both sides to the reciprocal power. So that's going to leave you x is equal to, and most of the time you can just type this in your graphing calculator and get the answer, but it's pretty easy to do without. All you have to do is rewrite this as a radical. So we know the denominator is our index of our root, so that's a square root. And then we have 4 cubed. Well, the square root of 4 we know is 2, and 2 cubed is 8. So this is x is equal to 8. Or again, you can just type it in your calculator and find the answer that way. All right? So those are all the important inverse operations you need to know. Now, you've been solving equations for a long time, so the rest is pretty much going to be simple. You just have to apply those new inverses when solving for x. Now, one thing you must always do is check for extraneous solutions when you're working with radical equations. Okay? So, to be honest, you should actually be able to do this first row without any assistance. So why don't you pause the video and give it a try. And then as soon as you're ready to see the answers, just click play and we'll go over them. So the first thing you obviously needed to do is subtract 3 from both sides. So that'll give you 2x cubed is equal to 54. Divide both sides by 2 to get the x cubed all by itself. So you have x cubed is equal to 27. And now you just have to get rid of the x cubed. So you cube root both sides. And the cube root of 27 is going to be 3. So for this one, we have x is equal to 3. So then you just want to quickly check. 2 times the cube root of 3, or 3 cubed would be 54, plus 3 is 57, so it works out just fine. Next example. First thing you should have done was subtract the 5 to the other side. So you have the cube root of x is equal to a negative 4. Now you just have to raise both sides to the third power. And that's just going to give us x is equal to a negative 64. And then, of course, you could check it. The cube root of a negative 64 is a negative 4 plus 5 is 1. So it checks out just perfectly. And the last one in this row. First thing you had to do is subtract the 2 to both sides. So you have the square root of 4x minus 7 is equal to 3. And then, just like we talked about earlier, to get rid of a square root, you just have to square both sides. And that's going to give you 4x minus 7 is equal to 9. Add 7 to both sides, and 4x is equal to 16. Divide both sides by 4, and you get x is equal to 4. And then, of course, you would plug it back in to double check to make sure that you did everything correctly. So 4 times 4 is 16, minus 7 is 9. Square root of 9 is 3, plus 2 is equal to 5. So that entire row works out just perfectly. Okay? So you have 2 more rows to go. Why don't you do the next row and then pause the video and see how you did. And then we'll do the last row. The last row is going to be the trickiest of all of them. So why don't you try the second row? All right, so let's see how you did on this row. So for this guy, you needed to take the square root of both sides. And that would give you x plus 3 is equal to plus or minus 4. Because remember, whenever you take the even root of a number, you always have to go with plus or minus when you're solving for x, of course. Subtract 3 from both sides and you'll end up with x is equal to a negative 7 and a positive 1. So now this is one where if you check, negative 7 plus 3 is going to give you a negative 4 squared is 16, and 1 plus 3 is 4 squared is also 16. So this example works for both. First thing you have to do here is divide both sides by 2, so x to the 3 halves is equal to 125. Then, to solve, you need to raise both sides to the reciprocal power, so 2/3. So that's like saying the cube root of 125 squared. So we know the cube root of 125 is 5. So we have x is equal to the cube root of 125 is 5 squared, which we know is 25. And again, you plug that in, it'll work out just fine. Last one in this row. You have to raise both sides to the reciprocal power, and you're going to get x minus 4 is equal to a negative 2 raised to the 5/3 power. Now this one is not going to work out to be a nice pretty number. So you're going to have to actually simplify that. So since we're cube rooting a negative, we can just pull the negative out. So we have negative cube root of 2 to the 5th power. 3 goes into 5 once with a remainder of 2. So that's a negative 2 cube root of 4. And that's, of course, still equal to x minus 4. So all we have to do is then add 4 to both sides, and you'll have your final answer. So x is equal to 4 minus 2 cube roots of 4. And you're just going to leave it like that. There's no way to write that as a nice pretty number. Okay? So the last row, like I said, is going to be the trickiest. If you have not tried that row yet, please pause the video and give them a try. I can pretty much guarantee you will have at least one with an extraneous solution in this row. Okay? Give it a shot. So for this one, you have square roots on both sides. So to get rid of a square root, you still have to square both sides. So this guy is just going to turn into 3x plus 2. But this, you have to remember, you're squaring both terms. So 2 squared is 4. And then, of course, the square root and the squared symbol cancel each other out. So this is equal to 4x. So then you're just going to subtract 3x from both sides, and you get 2 is equal to x. Substitute that guy back in, and it'll work out just fine because you'll have the square root of 8, which is 2 root 2. And this is also 2 root 2 when you plug it in, so you're good to go. This guy over here, the first thing you have to do is subtract 10 from both sides. So that's going to give you the square root of 6x minus 5 is equal to a negative 7. Square both sides, and that'll give you 6x minus 5 is equal to 49. Remember, a negative 7 times a negative 7 is a positive 49. And just continue solving. So add 5 to both sides. So 6x is equal to 54. And divide both sides by 6, and you get x is equal to 9. So then once you get x is equal to 9, you have to plug it back in like I've suggested. You do for all of these questions. And 6 times 9 is 54 minus 5 is 49. The square root of 49 is 7. And 7 plus 10 is 17. 17 does not equal 3. And the reason why this happened is because of right here. The square root of a number is not negative. So we knew that there was going to be no solution way back in this step. However, this is how you're going to get your extraneous solution. So x has no solution, but it has an extraneous solution of 9. Okay? So you always have to make sure you list what your extraneous solution is after you're done solving. All right, now the last one is Also a little bit tricky if you didn't catch the first step, but to get rid of this square root, you have to square both sides. So you actually have to square the entire left side, which means you wrap it in parentheses and square it. That's why all the previous examples, whenever I raise a side to a certain power, I wrap it in parentheses. So then that way you remember that this is actually x squared minus 8x plus 16 is equal to 2x. So you have to remember, you actually have to multiply x minus 4 times x minus 4. And then, of course, you subtract your 2x from both sides. So x squared minus 10x plus 16 is equal to 0. Factor to get x minus 8 and x minus 2. So x is equal to 8 and 2. And, of course, you have to substitute both of those back in to make sure that they work. So 8 minus 4 is 4. And the square root of 2 times 4 is also 4. So 8 works out just fine. If you plug in 2, 2 minus 4 is a negative 2. But 2 times 2 is 4, and the square root of 4 is 2. So a negative 2 does not equal a positive 2. So in this one, we have x is equal to 8 with an extraneous solution of 2. Now, another way that you might see that written is called set notation, where you put the solution in squiggle brackets, and then you put the extraneous solution in parentheses. Okay, this means solution, and this means extraneous. But you can just write x equals 8 and extraneous is equal to 2. I just wanted to show you what set notation looks like. All right, that's it for this video on solving radical equations. This is Longo, and I'm out. See you, bye.